Welcome back to the realm. I'm taking Grace. Today we're moving on to the most crucial part of our Tarkov inventory build, the foundation. In episode 1, we set up our data, but today we're going to give that data a place to live. We're building a unique item ID system so the game can track every individual item instance, and after that we're creating the grid component. This component is the brain of the system. It handles the coordinates, the item placements, and management. If you want to become a skilled developer, you need to master how components talk to data. So let's see how that works. First up are the unique IDs. Last video, we created a struct that has our item data, occupied coordinates, amount, and unique ID. It becomes a nightmare to query items since it's possible that all three of these first variables can be true at once. With unique ID, every item will have an identifier that it carries with it no matter which grid it belongs to. This way we can pull up the exact item we need or see if it's the same item that we're hovering over. Second is the grid component. We aren't just making a UI widget that looks like a grid. We are building a blueprint component that creates a mathematical coordinate system of X and Y. This makes our system modular. You can slap that component into a backpack, a chest, or even a vehicle, and it'll just work. So first up, we're going to start by generating those IDs and then moving on to the coordinate math. So by the end of this video, your component will be complete and your item ID system will be finished as well. Just a reminder that if the math for these coordinates is throwing you for a loop, don't panic. Head over to the Discord and check the help forum and post a screenshot of your graph, and the community or myself will help you troubleshoot. And if you can't wait for the next video, check out the Noble membership on the website. For only $10, you can get the full 12-episode module immediately, plus the project files to compare your work against mine. Alright, let's get in there. Alright, the purpose of this video is going to be making the component that's going to generate the coordinates for our grid, and then the component is also going to hold all of the physical items that are attached to that particular grid. So we're going to create basically like a package. So we're going to have the component, which again runs the coordinates and holds the items. Then that component's going to create the widget grid. It's going to own the widget grid. And then that widget grid is going to create all of the background slots that are in that grid, which I showed you earlier. So the background slots are going to have their own unique kind of role in it, but they're going to be owned by the widget grid. So basically we're creating like a package. Every single grid is going to be self-contained and managed within itself, okay? So yeah, today we're going to be doing the component itself. So let's go to content and we'll make a new folder for components. Okay, and this will be a blueprint class type actor component because anybody or anything we want to have an inventory, we want to be able to plug it in, right? So we'll just say BPC inventory, yeah, inventory. Let's call it grid inventory. I can't spell inventory grid component. I was just thinking the inventory grid widget is what I named it in my prep project, so I think I'll just name it grid widget or something like that, just to kind of keep the naming separate, just so it's easier to debug. Anyways, okay, so we're going to open this component up. Actually, before we do this, we're going to do the unique ID that I was talking about last video. So basically, the unique ID will keep track of all of the items throughout the game, basically, and because we're going to be changing which components and which widgets that item is assigned to quite a bit. So we want to make sure that it has an item ID that's going to be consistent across everything in here. So yeah, sorry, we'll close this for now. We're going to go and create a blueprint function library. So we'll go blueprint function library, BPL, let's call them standard functions. In order to put something in a blueprint library, it's got to satisfy two requirements. The first one is it's stateless, meaning that it does not connect directly to anything in terms of like blueprint content. So you're not going to create a player reference in this. You're not going to create a reference to an image. You're not going to create anything like that that's in your content drawer. It's got to specifically just be data that's going in and out of here. And then number two is like reusability. So if you're going to be using a function quite a bit, then obviously using this function library would just make your life a lot easier. You can call these functions anywhere in the engine, and you don't need a reference or anything to get them. Okay, so we'll hit compile. We're going to make a new function. Let's call this one debug error print string. We're going to be putting print strings quite a bit in here, and they're not specifically going to be to check if something's working. It's going to be checking if we had a failure somewhere, just so we know where the failure is. Okay, so we'll get a print string. We're going to drag the in string as an input. We'll just say error message. There we go. Okay, and then we'll just set it on screen for like 5 seconds, and we'll make the color slightly different, maybe like yellow. That's it. And then the world context object, I believe, doesn't matter, so we don't have to worry about that. But sorry, we're going to break the string and we're going to get an append node. Okay, we'll drag A into error message, and then we are going to drag out of here, and we're going to get display name. Okay, and we're going to drag this, and instead of object, we're just going to say self object. Let's add another pin, and let's replace this just so there's like a space between the two of these. Anyway, so this is going to be the error message we type in, where it's going to be like failed to add to grid or no item type found or something like that. And then we're going to plug in a self. So whatever blueprint it's this error is in, it's going to come in here, get the display name, because if we have 4 grids on screen, they're going to be grid 0, 1, 2, 3, right? So it's going to be harder to know which one is actually failing. And then it's going to print the string, okay? Our error message, item type not found in blah, 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 right? Let's actually add another pin and add that in. Actually, maybe we can just do it. Sorry. Maybe we'll just do it here. We'll just, because I already added a space, we'll say space in space, and then that will just make it cleaner. Okay, so that's one function. The other one is going to be find item ID by index. Pardon me. Find item ID by index. Okay, this is going to have an input for our items. So our item structure that we made. Sorry, items with an S. And then this is going to be S underscore item or inventory item. And then we're going to make this an array. Okay. One more, and it's going to be the unique ID. Okay. And this will be an integer and just a regular single. Okay. So we're going to plug our items in from our inventory component, and we're going to get a for each loop. Why am I thought I fixed this. There was an issue with Aura specifically, where it was removing the shortcut keys. Maybe I'll try it in regular blueprints and see if it works. Anyways, so yeah, we're gonna get a for each loop. We're gonna break this or split this, and we're gonna check if the unique ID from our function input equals the unique ID from these items, okay? And we'll move this up just a little bit. We'll get a branch. Okay, they are working. It's just the F1 wasn't working for some reason. Okay, and then if it's true, we're gonna return. We're gonna return that we found something. Whoops. So the return value will be found. And then we're going to output this index. Okay, so we'll just say, yeah, array index is fine. Okay, so that's going to basically find an item inside of the specific inventory based on its unique item ID, right? So this will be used more later when we start getting into stacking items and all that kind of stuff. But yeah, we're gonna make this function now. Okay, because we want to actually do some stuff with this. So let's go into our game instance now. Oh, I'm sorry, pardon me. We're gonna make some interfaces first. We'll go to blueprint interface, and we'll call it BPI underscore GI. Will be specifically for our game instance, and let's make a new folder called interfaces. Throw that guy in there. All right, so BPI GI, we're going to open that up, and we're going to assign item ID. This is only going to have an output of a ID, okay, which is an integer. Okay, so this has been created. Now we can go into our game instance, framework, game instance. We need to go to class settings and implement the interface we just made, BPI GI. We're going to hit compile. We're going to make a variable called last item index or last item ID, and we'll make that a integer. And all we need to do, we're going to compile. We're going to leave the last item ID at 0. We're going to go into our assign item ID function in our interface, and we're going to drag last item and plus plus. Okay, so this will add 1 and set the last item ID as the new amount. Okay, and then we'll output that. All right, so the first item that spawns in, it's going to add 1, and then so that's going to be 1, and then it's going to output that as the ID. And then the next item, it's going to add 1 to 1, and then it'll be 2, blah, 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 okay? That's literally all it is. You don't need to create a list to keep track of all the items, because this should be basically consistent across your game, right? When you save your game, like before you close your game and your game instance gets destroyed, you should be saving the last item ID in here, right? Because as you take items back to your HUD world, they're all going to have their own unique ID, and we need to make sure that no ID ever has, or no item ever has the same ID as another item, right? So, or else your game's going to break. So, okay, so that's all we need in here. Now we're going to go into our components. And, okay, so we're going to open the full blueprint editor. And let's start off by making some variables. There's quite a few variables in here, and there's quite a few functions, actually. There's going to be a lot of functions in this tutorial series because it's just, the graph gets messy otherwise, right? So, and you want to do reusability when you're doing different blueprints and stuff. Okay, so first we're going to do a coordinate slash slot map, we'll call it. This is going to be the index coordinate, and this is going to be a map. Okay, and the other one up here is going to be the, we haven't created them yet. Let's create them right now just because we will need to reference them. So go into UI, we'll make an interface widget blueprint and user widget, WBP underscore grid widget. And well, we can just duplicate it because there's nothing in it. Okay, and this will be WBP underscore slot BG. Okay. Yes. Okay. So once again, these components are going to own the widget. It's going to do the creation and everything. And then the grid widgets are going to own and create all of the slot BGs that are in our grid. Okay. Every single coordinate is going to have a slot BG. Okay. So if you have, you know, if it's a 5x5 slot, you're going to have 25 different slot BG widgets on screen. Okay. Just to give you an idea. So we're just going to basically have a way for us to map which slot BG belongs to which coordinate, okay? So, yeah, so over here, now we're going to get a reference there to our slot BG, okay? Object reference, and that's all we need to make for that. Next, we're going to do, how big is this grid? So we're going to do slots wide, we'll just say size. Slot wide size, that will be a integer, and we're going to get rid of the map and make it a single, okay? And then slots high. Yeah, again, I'm gonna leave the naming convention the same as my prep project so I don't confuse myself. This will get quite confusing. I think we do one of the things in this video here if I can remember correctly. So anyways, these are gonna be instance editable, and so we can set these in every single component that we put into the world. How big is your slot, or how big is your grid, right? Okay, next, we need to know how big the slot sizes are going to be. It's going to be the same for every single one in here. This is going to be a float slot size. We're going to hit compile and we're going to set this at 64. Okay. And this is again staying the same for everything in this series because we don't want the slots to be different sizes because it's going to make all the items not line up properly and it's going to be silly. So, all right. Next we'll do max X coordinate. This is going to tell Unreal Engine, the maximum size of our grid. So if we're checking for a slot, if a coordinate exists and it exceeds our max X coordinate, then it's going to return false. Okay, and we'll make another one for Y. Those are not going to be instance editable. Let's put these in some categories. Let's say grid variables, we'll call them. Okay, and then we'll just drag all these in there because we want to keep this organized. Okay, so there's all those. Okay, so we'll make grid type variable, and that'll be a gameplay tag. We're gonna, expose this on spawn as well. Grid type, instance editable. I believe we expose on spawn, but I actually can't remember. We'll leave it disabled for now, and then we'll see if we need it later. But anyways, so yeah, gameplay tag is gonna obviously tell everything what kind of grid this is. If it's gonna be a key item grid, or if it's gonna be a storage grid. So grid type, we're gonna be checking off one of these. We didn't add storage. So that's a good one to add here. Grid type, we will add subtag storage. And we don't need to add a subgrid for storage because if it's a storage, it's going to only have one grid anyway, right? So yes, that's what we'll set that as for like anything in the world like that. Okay, the rest is going to be either widget related or item related. So first let's do the stuff for the let's drag this in grid variables for the widget. So we're going to do grid widget, and that will be the WBP grid widget, and that's an object reference. And then we're going to have, I think, parent panel. Oh no, we do need that. Parent panel, okay, and that is going to be a panel, panel slot, yes. Panel slot is just generic. It can be a horizontal, vertical box, a horizontal box, a scale box. So this is pretty generic. We'll just need to cast later to the specific one that we need, which is going to be a horizontal box. So, I mean, shit, can I just say, we can figure that out later. Anyway, so parent panel, so I'm just going to make this category widget, basically widget, right? So I'll put all that stuff in there. And is there anything else widget related? Yes, we'll do auto create, and that'll be a Boolean. And this is going to be set in the event graph of this begin play. We're checking if we want to automatically create the widgets for this component or not. This basically is going to only be true for player stuff. We're going to create all the player stuff right away so it's available for us. But for crates and all that stuff in the world, we don't want to create those widgets until we actually interact with those items. That way we're saving memory, not loading 200 different grids into the world that we don't need, right? So that's what that's going to be there for. I'll put that into widget, and that needs to be instance editable and exposed on spawn because we want to set that in the beginning there. Okay, now we're going to do item stuff. So we will do items, which is s_inventory item. That's going to be an array. That'll be instance editable and exposed on spawn as well, because we're going to set those items when we spawn these in, which will more specifically for our player than anything. But anyways, so then we need to add the items that we're going to allow in this grid. So we'll say item types allowed. Okay, that will be a map as well. So first we're going to do e_item type, and that will be a map. Okay, and then a Boolean will be the second one. So we're going to hit compile. Now we're going to edit this. This is going to be instance editable as well, but not exposed on spawn. We're just going to set this and forget it. Okay, so we're going to add one. See how it added none? Because last video I told you guys to add this because it's going to be annoying. I'm going to select first aid. I'm going to add another one. It's going to add none. If I try to add another one, it's going to say, if I can move my fat head there, cannot add a key item to the map while another key with the same value exists, right? So that's why we added none. So we're just going to add all of our different enumeration options. So there's all of them. By default, you should just check them all off, to be honest. And then if you want them because otherwise it's just going to cause errors for no reason while we're trying to like create this and debug it. So just set them all true for now. And then anything in the world that you want to not put certain things in, then you can check off the ones that you don't want, or uncheck, I guess. Okay, so those are the variables that we need. Let's start with event begin play. So first off, we'll get rid of tick. We're not using it in this component. First off, we have to create an initialize grid function. So it's going to create our coordinates that we need for our grid. Okay, so initialize grid. Okay, first we are going to just confirm that this is clear. So we're going to clear all the components and the slots associated with this because, oh, sorry, I didn't mean to set it. I meant to just grab it. Yeah, because obviously if stuff does exist, it's going to just mess everything up. So this is just kind of a failsafe to make sure that we have cleared our stuff. Next, we're going to get our slots wide and slots high, and we're going to set our max X coordinate and max Y coordinate so that we can make sure that those are correct. So the Y is for X. So actually this is where I can, okay, so wide equals X. So we'll say X slots wide and Y slots high, just for simplicity's sake. Okay, so we'll do that. And then we're going to -1 because 0 is not included. So -1, and we're gonna plug that in. Okay, so yeah, like I said, zeros, when we're setting our wide size, like we're going to be like, I want it 5 slots wide, right? So I want it 5 slots wide. Obviously 0 is included in all of the coordinates. We don't want it to create an extra, basically column, right? Or row. So yeah, we're going to minus it by 1 and set that as the max coordinate, and we're going to do the same thing with this guy. Alrighty, there that is. Next, we're going to create what's called a nested loop. So this is a common programming practice for creating grid type things. So we're going to drag it here, and we're going to get a for loop. Okay, and so this is the outer loop. So we'll just name that as so in the comments here. Outer loop. Outer with two T's because literacy is not a thing for me. Anyway, so we're going to first start with the slots high. Okay, so how many slots high there are? You know what? Sorry, we're going to just copy this because we want to do -1 again anyway. Okay, so number of slots high, that's going to be our last index. Okay, the reason we're doing high first is because the outer loop is going to run basically all of the width of stuff. So I'll put the image on screen just to make sense of it here. So it's going to create everything to do with the X first. Okay, so we want to know how high it is, so we know how many rows we need to make. Okay, so the rows are going to be the X, and the columns are going to be the Y. So we need to know how high we are in order to know how many X coordinates we need to create. So hopefully that makes sense. So we're going to start with the outer loop. So the loop body is going to execute, and then we're going to get another for loop. This is going to be the inner loop. For loop. Here we go. Okay, so this is going to be the inner loop. So we're just going to copy slots wide. Pardon me, not cut. Copy, paste. Okay, so there's that. This is the inner loop. We're going to be doing nested loops quite a bit in this series, so you'll be very familiar with the concept by the end of it here. So every time this loop body fires, Now it's gonna run this for loop, and it's gonna fire the loop body until it gets to the last index, okay? Then it's completed, okay? And then it's gonna come back to this for loop, and then it's gonna go to the next index, which is, in this case, 1, right? And then it's gonna do the loop body, and then execute all of these inner loops until it gets to the last index. So basically, this is how you create a grid system, right? Okay, so that's set up. However, we're just gonna make our lives easy. We're gonna right click this index and promote to local variable and call it current x, or current x. Okay, and we'll plug that in, and then I'll just move this back just to clean it up a little bit, and then we're gonna do the same thing here, promote to local variable, current y. Okay, and there it is. So these are going to be the current XY coordinates for the particular coordinate that we're doing, right? Okay, so once we have gone all the way through here, we're going to grab the coordinate slot map, and we're going to add under map. We don't want to do operators add, we just want to do under map add. Okay, so now it's giving us the two options to populate both of these sides, so the coordinate and the slot BG. The slot BG we're going to leave empty because we're going to create those inside of our widget grid for now. Okay, we're just going to create the coordinates that our widget grid can grab later, and then run a for each loop on all the coordinates, and then create a slot BG for each one. Okay, so out of here we're just going to, I mean, we can split this, I guess, just keep it clean. Okay, and then we're going to plug in current X and current Y. Okay, this completed needs to be left empty because when we complete this for loop, we want to go back to this for loop. But completed out of this one, we're going to get a return node. Okay, and we're going to exit. Okay, next we're going to, we'll hit compile, we'll make another function, which is going to be assign item ID. Okay, this is going to have an input of items, and that'll be our S underscore inventory item and an array. Okay. The reason we're doing it this way is because we want to plug in different inventory items, not necessarily the one that's attached to this grid. We might want to assign an item ID to another grid, right? So we just want to keep this generic enough that we can do that. Confused why my for each button shortcut's not working, but that's fine, whatever. Yeah, we're going to get a for each loop for this. Now we're going to get the game instance. Okay, that's the generic node, and then we're going to get the interface that we made in the beginning. So that'll be assign item ID message. Okay, we're going to plug that into the loop body. So this is slightly confusing. So this is another reason why we had to do this. So we need to get the items array, which is the sorry, not that one. That's the wrong one. Get items. It's got to be the function input. We'll uncheck context sensitive maybe, and we can get the right one, because we don't want it to be default, do we? No, we want literally this one. You know what? Let's just rename this like array, just so we know that we're getting the right one. So get array. Oh, okay, it was just weird. All right, anyways. So now we can rename this to items, just so we know we have the right one now. So yeah, it has to be the function input, not this one, right? Or wherever it went, items. And we need to get, so this is misunderstood type of thing here. So, context sensitive, there we go. Okay, so we need to, usually we get a copy, and in this case we need to get a ref. So the difference between these two things is when you get a copy, you're getting a copy within a function. Okay, so the get copy is going to be basically invalidated after we leave this function. Okay, when we get a ref, we get the physical item in this array, and we are going to permanently set the data in there. Okay, so we're going to get a ref, and you'll see that this is a diamond and not a circle. That means that you're getting a reference and not a an actual copy of it, okay? If you get a copy of this, this is not going to work, and your item ID or unique ID is going to be 0. Okay, it's not going to permanently change your ID, so that's why you need to get a ref instead of a copy. Okay, and I'm going to show you guys a node that I'm sure is going to change your goddamn life, because I discovered this actually more so during the prep of this tutorial series, and holy shit, it changes your freaking life. Okay, so we're going to drag out of this ref, okay, and we're going to set member. See, I'm sure you've seen this before, and you're like, I have no idea what that means. I'm not going to worry about it. I'm not going to use it. This, my friends, I'm going to do it the long way to show you why this is awesome. So normally you're going to have to get that, and you're going to have to break it, and then you're going to have to, oh yeah, sorry, we got to plug this in too. And then, like, for example, we're going to, I'm just doing this the long way just to show you guys, what's going on here. So yeah, then you would get this output, you'd have to make an inventory item, and then you have to make sure these are all plugged in, or else you're going to lose that data, and then you got to plug this ID in, right? That's like the way I was doing it, and you can, see that this gets a little messy, especially when you have a lot of these different things that you're setting with different items. Like this, my graph was so messy, and then I discovered whatever. I did this fix for that. Drag out of here, set members in inventory item. Okay, so this is going to only expose the things that we want to set. Okay, so in this case, we only want to change the unique item ID. It's going to only change that and then reset everything else to be the same. Okay, holy crap. That was an option this whole time, right? Yeah, so we're going to plug a unique ID into here, and now we have gotten a reference to this item in this array, and we've set the unique item ID, and now the struct is still intact. Okay, once we're done this, we're going to come out of completed and go out of this return node. Okay, all right, so in the event begin play, now we're going to initialize our grid. Then we're going to get inside widget auto create, we're going to get auto create, right click, convert to a branch. If it's auto create is true, then we're going to assign our item IDs and we'll plug in our items. And then later I'll just add a reroute node and add a comment here. We gotta, whoops. We gotta create our grid. Okay, so we're gonna make that later, but that's where we gotta put that, okay? That's the begin play. We're gonna also get event end play. This is called when a component is destroyed. So we got to create an event dispatcher called component destroyed. Okay, we're going to call that, and we're going to subscribe to that event inside of our widget, our grid widget. So when this component is destroyed, i.e. when we pull our vest or our backpack off and we want to destroy the grid, we're going to destroy the component, and then it's going to call a component destroyed, and then our widget's going to destroy all of its slot BG children and then destroy itself. Okay, so that's what that's going to be doing. And then anything that has an actual hard reference, we need to clear. So grid widget, we need to make sure it has nothing in it. Parent panel, we also need to make sure there's nothing in it. That way there's no dangling pointers to anything, and we can garbage clean up this component, okay? This is very, very undertaught, by the way. This is very, very important that this end play exists on all of your blueprints, okay? Okay, it's time to create another function called calculate target coordinates. So we're going to make a new function, calculate target coordinates. I have a bad habit of doing this, and apparently it's not good, I'm told, but I don't understand why myself. Putting spaces between your words is apparently a bad practice. I know in C++ it actually matters, but I'm not sure if it matters in blueprints. If anybody has the answer to that, I would love to know. But anyways, so yeah, we're gonna go into target coordinate, calculate target coordinates. This function is pretty beefy and it's pretty complex. So I'm gonna try my best to explain things as I go. But if you need to rewatch this part, like to understand it, by all means. Okay, first we need a starting coordinate. Okay, which will be a single index coordinate. We need to know the width of the item. So we'll say width of item, I guess, and then that'll be an integer, and same thing, it'll be, sorry, height of item, another integer. We need a can rotate in here, that'll be a boolean, and we need try vertical in here as well. Okay, so the purpose of this thing is we're going to first we're going to check if the item can even fit in the grid by checking the width and height of the item, and checking the max X and Y coordinate of the grid, and a couple other things I'll show you guys in a sec. But yeah, we're checking to see if the item can fit in the grid in general. If it can't, then we're not even going to bother running this. Then we're going to check horizontally if the item will fit. So it's going to grab this starting coordinate. We're going to check if that coordinate is empty, and if it is, we're going to check basically the width and the height of the item, but the neighboring coordinates to see if those ones are free. And if they are free, then we're going to return that we can place the item. If not, we're going to then try vertically if it can rotate, if we can place this item and do the same thing. Okay, so that's what we're doing here. First, we're going to get a boolean off of try vertical. We're going to call this twice in this other function that we're going to make, and just so we don't have to do it twice, right? So that'll just be checked true for the vertical portion, and then we can just skip the horizontal portion, not have to worry about it. Okay, so I'm going to show you guys math expressions because boy, oh boy, they're handy. So we'll type math expression, and right at the bottom there, add math expression. This is going to create a collapsed graph, and the name of this graph needs to be the math formula that you want to do, okay? In this case, we're going to be doing x plus width, so the x coordinate plus the width, minus 1, and is it less or equal to max x coordinate? Okay, so that's my function. I'm gonna hit enter. You can see it just created all of these inputs and it created the formula. So this is the same as doing this, like except instead of doing all of these nodes, you can just do it in literally one singular collapse graph. You can open it, you can see that it's read only, and that's exactly what it's doing. Okay, so that's a math expression. So if you guys haven't been utilizing those, I recommend that you do because they're awesome. Okay, so now all we need to do is, first of all, change all these to integers. Integer. Okay, so now we're going to plug in our starting x coordinate, the width of our item, and the max x coordinate. Okay, so it's doing all the math for us, and then we're going to get a branch. we're going to disconnect this because we got one more. Well, actually, we got 3 more of these to make. So we're going to duplicate this so we don't have to do all the work. And we're changing the X to a Y and the width to a height. And then the max Y. And I'm just going to check that. That is what I have. Okay. So, damn it. We got to change all these back to integers. God damn it. We're just trying to avoid this. Okay. Same thing. We're going to get we can probably reuse the starting coordinate from up there, but we're going to get the height of item, and then we're going to get our max Y coordinate. Okay. So height of item, max Y coordinate, and Y is going to go right there. So there's our 2 math expressions for this, and we're going to get an and Boolean and plug these in. So we're going to make sure both of these are true in order to return true out of here. And I can drag that right up there and probably slippity slide all these up here. Oh yeah. All right, so that's the horizontal portion of this, and we can comment box this and just say checks if item can fit horizontally in grid. And then we got to do one for vertically. So it's going to be pretty much exactly the same. We're just going to flip a couple of variables. So we're going to copy these, paste them down here. The formulas, I'm going to type the formulas and then we can just make a match. So it'll be Y plus width minus 1 is less than or equal to the max Y. And then this one is, sorry, I had to flip-flop some of these, so like the formulas in my notes aren't quite correct here, so I'm just making sure that it's the right stuff. So this is X plus height minus 1 and max X. Yes, okay. So that's what they are. We are going to just cancel these and then make sure these are integers. Just literally imagine how messy this graph would be if we had all of these math things. Like, it's just gross, right? So anyway, so we got width, and we got X goes here, height of item goes there, max Y and max Y goes here, X goes here, and Y goes here. There we go. Okay, I don't know if we want to scramble those up, probably. Or unscramble these, I should say. Okay, perfect. All right, so that's that, and we'll get an AND node for this as well. And we'll do a branch from this. And if we are not trying vertically, then we can just move all this ahead here. Then we can try this. Okay, there we go. And this checks if item can fit vertically in grid, I guess. Perfect. Okay. Okay, and if it doesn't fit, could put an error here, but the error gets a little annoying just because if it doesn't fit, it'll say it doesn't fit, and then it's going to try other grids, so it might pump out like 10 of these errors before it like finds a slot that's available or whatever. So we're just not going to bother to do that, but we will do a return node here for us failing. So let's add a output. We'll add one called within bounds. Within bounds. That'll be a Boolean. And this one we're going to make rotated to let us know that we need to rotate the item. And then one more, which will be the coordinates. That'll be index coordinates, but an array. All right, so that checks if we can fit in the grid, and now we need to check the actual slots and make sure that they're available. First thing we're going to do is we're going to do another nested loop. This one is going to be, so we'll just get a for each to start, or for loop, pardon me, to start. We will do another math expression, so we'll just say add math expression, and this one is going to be x plus width minus 1. Okay, and once again, we got to make sure that those are integers. Okay, and we're going to plug in our we'll get our starting coordinate and we'll get our width. We'll copy paste those. We'll do x plus the width minus 1, and then that'll be our last index, okay? So the idea behind this is we only want to check the basically the slots that are going to be covered by the item. We don't want to check every single coordinate to see if it's available, because that's just kind of a waste of work, to be honest. If we're going to have a lot of nested loops, you do have to manage the work a little bit. Otherwise, especially because this calculate target coordinates is going to run every single time you hover over a different slot BG. So if there's 100 slot BGs on there, there's a potential chance that this can run 100 times. It is really, really quick, like negligible. But at the same time, you want to just reduce the amount of work that Unreal Engine's doing if you don't need to do it, right? So that's why we're doing it this way. We're going to copy these two, paste it over here, change the formula. This is going to be the y now. So we'll do y plus height minus 1. Make sure that formula is correct in what I put in my notes, which it is. Okay, so now we're going to connect the Y and the height of the item. Just don't want to type all that out again. Okay, and we're going to get another for loop, and that is going to be the last index for this for loop. Okay, and once again, we're going to probably create some local variables of these, so we'll promote this to a pardon me, undo what I just did, local variable. There we go. Current X. Okay, and we'll plug that into the loop body, and then we'll plug this into the loop body, and then we'll skinny this up a little bit. Actually, sorry, we won't, because we need to come out of completed for that one, so. Okay, then we'll, same thing, right-click, promote to local variable, and current Y. And then we are going to find the coordinate here, so we're going to get coordinate slot map. We're going to find, and we need to make index coordinate, okay? And we're going to plug in our current X and our current Y. Okay, and then we are checking if this exists or not. So we're just going to get a Boolean out of that, or get a branch out of that Boolean. And then if it does exist, we are going to grab another local variable called target coordinates. Okay, that'll be an index coordinate, and that'll be a array. Okay, and then we're going to grab that. We're going to get it, and we're going to add. And if this is successful, we are going to add it to this array. Okay, so that's it for horizontal. Now we need to do vertical. We'll just call this calculates hovered slots, because that's, oh, sorry, and horizontal, because we're going to copy paste this and do vertical and then change some formulas. All right, so now we just got to copy and paste this essentially, and then it'll be the vertical for this. Okay, so we'll copy, paste, and we will go down here, and we'll move this all the way over here, because if we don't find a slot or coordinate map, so yeah, basically like how this will work is, once again, I'll see if I can put it on screen just to make it make sense, but first starting coordinate is slot, you know, 40, right? So it's the literal top corner slot of our inventory. That is a valid slot, right? So that's a valid coordinate. So when you check this is going to pass true because that is a valid coordinate. However, the second pass of this, it's going to check is slot 50 a coordinate, and it's not, because it's off of the map or off of the grid, right? So that's where this is going to return false, meaning that we can't place the item there because it doesn't exist. Then we're going to try this is false, right? Or is vertical. Try vertical. The math for this needs to change. I'm just going to make sure I have the formula here so I don't mess it up. But we have a Y plus width now. Okay, and of course we're going to change that back to an integer. So Y plus width minus 1. And this is going to be the outer loop, and it's going to be for the columns. Okay, and then this will be for the rows. And this will change to X plus height minus 1, correct? Yes, correct. Okay. Okay, the other difference that I just saw in my notes is the X and current X and current Y are swapped. Okay, so the current Y will be set out of this one, and the current X will be set out of this one. Okay? Make sure those are all plugged in. Once again, we're going to get this. We're going to check and see if the slot is like these coordinates are actually valid. Then if they are not, then we're going to come out of here and we're going to exit this function because we cannot place this item. Yeah, anyway, so you can't, so this is all blank because we'll check rotate anyway because we're on vertical, but yeah, it doesn't matter because we can't place this item. So anyways, back here, if we've run through all of our columns and rows and we've come out of completed, that means that we did find a slot, realistically, that we can place. So within bounds is going to be true, and rotate will be true, and then we'll plug in our target coordinates because we want to output the ones that we found were available. We're also going to copy this return node and paste it here because the same will be the true for this. If we've hit a return node from this for loop, that means we have found all the slots are valid, and we've added them to our array, and we're going to output that we can that this item will fit in the grid, and we will not rotate it here, and then we will output the coordinates. Okay, that's this function. So hopefully that made sense to you all. Okay, next we're going to create, we're basically creating all the functions that we're going to call from other blueprints right now. So that's nothing else is going to go into the like the begin play or anything like that. So this next one is going to be called find item by hovered coordinate. Sorry, it's going to be just called find item by coordinate, I guess. This one is going to have an input for index coordinate. We'll just say coordinate index coordinate. We're going to get our items, and we are going to get a for loop, or for each, pardon me, loop, and plug that in here. Okay, we're gonna do another nested loop out of this. So we are gonna split this struct pin. You'll see we have a array for occupied coordinates, and we are gonna get another for each loop, okay? And we're gonna check each coordinate that this item occupies to see if it matches this coordinate. This is not run that often, and we generally speaking won't have max items. Like, for example, if you have a 5x5 grid that's 25 slots, I would say super rarely are you gonna have 25 slots in a grid that's got 25 slot BGs. That would mean it's just full of ammo. It's probably not gonna happen. You're gonna have a lot of stuff that's gonna be taking up like 2x2 or whatever. You're probably gonna only spawn a maximum of 7 to 10 items in that storage grid or whatever the case is anyway. So, okay, so we are going to now take this, and we can't, unfortunately, compare structs, right? So if I put equals equals, it's not going to let me do it. So, unfortunately, we got to split this, and we got to basically create two of these, and we'll do X and Y, and then we got to get the coordinate and split that. And then same thing, got to plug in the X and Y and Y. We're just checking to see if those, and we're going to get an AND Boolean, and then get a branch. All right, so if these are true, that means we found an item. So we're going to get the items array once again, and we're just going to get, just because we've split this struct pin, so it's all messy. So we're just going to get the array of this index, and then return it. Okay, so this will be item. So once again, we are checking if any items in this item array match the query component coordinate. Okay, that's all we're doing in here. So this will be used later for finding a hovered item, right? So if we're hovering over an item and we're saying, hey, what is this hovered item? And we're going to give the coordinate that we're hovering over, and then it's going to plug this in, it's going to search it, and it's going to find it, and then we're going to output the hovered item. Okay, that's what this is going to be used for. Okay, next we're going to make another function called item in bounds. Okay, so we're checking two things that are in bounds. Number one, I think we made this a macro? We made it another function. So we're just going to make another quick function here. It's going to be a pure function. We're going to be checking that we're going to get the item, and that'll be an S inventory item. Okay, we are going to break this, and then we are going to check the item data, and we're going to get the item type, and then we're going to compare that with our item types allowed. Okay, so we're going to get item types allowed, we're going to find, and we're going to return back if this is the value associated with the key. This is the one we want. So we're going to find the item in our map, and we're going to check and see if it's enabled. If this is disabled in any way, then we're going to return false, and we're going to not allow this item to be placed. So we'll get a return node, and we'll just say accepts item, I guess, or accepted. Okay, right here, perfect. Okay, and then if it's true, we're gonna return that we do accept this item. All right, so let's hit compile. This is gonna be a pure function, so we're just gonna check pure. This means that it doesn't need to run the execution wire at all. We're just gonna check if it can do this. To be honest then, I don't think we actually need this branch. We can just do this. Just like that, okay? So is the item type accepted by this inventory grid? And it's gonna return true or false. Okay, so that's all it's going to be. We're going to go back to this new function. Oh, sorry, did I not name the last one? I didn't, sorry. We'll just say, does grid accept item? Okay, well, that's what we're going to call it. We'll compile. That's the first thing we're going to check is we'll make sure this item is an input on here. And get a Boolean. Okay, and then we'll get a return node out of this. And this is actually where you can use that print string thing we made. So we'll make a debug error print string. Okay, and we're just going to say item not accepted. And then we're going to drag it here and get a reference to self. Okay, remember that error message is going to say item not accepted in, and then it's going to print the name of this. So it's going to say inventory grid 0, 1, 2, 3, 4, whatever one it is, right? Okay then. So we are going to finish this function off here by adding the calculate target coordinates. Okay, so this is going to check all of the coordinates from our hover coordinates. So we're going to I'll just drag this over here to get a pin, and then I'll disconnect it, and we'll just rename it hovered coordinate. Okay, and then I'll get hovered coordinate, and then plug it in here. So it's nice and neat. We are also going to plug in try vertical and then disconnect that and then get try vertical. I don't know. I hate messy graphs. It just drives me crazy. So get try vertical and we'll plug that in. Okay, so to get the height and width of the item, if we can rotate it or not, we're going to need the item data. So we'll just get item, which will be the function input. And then we're going to split this. And then we're going to, out of item data, we're going to get can rotate. And then we're also going to get, we should create another little mini function here for this because we need actually get this a couple of times. So new function, we'll just call it get item dimensions, or get item size, we'll call it. This will be a pure function as well, and we're just basically gonna get the item data as the input, PDA item data object reference. Then we're gonna get, what did we call it? I think it was get number, right? Yeah, get number of slots high and get number of slots wide. Okay, and we are gonna just literally return those. Okay, just like that. And the reason we're making it a function is because we want to be able to call it in other blueprints, right? If we make it a macro, we can only call it in this component, right? So, all right, let's make it a pure function, and we'll hit compile, and then we'll go back to the item in bounds, and we'll get that. So we will grab the get item size, and we'll plug in wide and high. Wide and high. All right, so we're going to check if we're within bounds, and if we are, we're going to return that we can, that we are in bounds. We'll just say, we'll make a new output here, Boolean, we'll just say accepted and in bounds. Boom. We'll need another one that's going to be our target coordinates. We can just drag this over here, and we'll just say target coordinates. Okay. And one more for should rotate. We can probably shuffle these up, eh? There we go. Okay, and let's plug that in. We don't need this branch again. Yeah, so yeah, we don't need the branch just because we can just output literally if it's true or false, right? And then it'll handle it from there. I think that's it for this function. It is. Let's just comment box this and just says finds items hovered, hovered. I don't know what I was spelling there. Hovered coordinates. Okay, we'll hit compile. Okay, so that should be it for this video, but I just want to show you guys that this actually works, because I did want to make videos that have something that can basically showcase that you've, done something at the end of it. So what we're going to do here is I'm going to create a debug key. We'll add this grid into our player state just to have it somewhere. So we're going to open up our player state, okay, in our framework folder. And we'll open the full blueprint editor. What we're going to do, we'll just add this BPC inventory grid here as part of the player state. And then on event begin play, we are going to, let's delay till next tick, just because some things may not be in the world yet. So sorry, delay until next tick. Okay, so that should give enough time for the BP inventory grid to run all of its stuff. And then we're gonna get its coordinates, get coordinate slot map, and we're gonna do a for each loop map. And then we're going to print string, and let's append it just to make it neat-ish. And add 3, and then we'll split this, and we'll do X, and then we'll do like that up and down thing, and then Y. Okay, and this is just gonna print all of our coordinates that it's created. So we have not set this yet, so we got to click on this and do slots wide, blah blah blah. So we'll do 5 and 5 just to make sure that this works. Okay, and we'll hit compile. Now let's get this out of the way. Let's hit start. There's all our coordinates, 0 all the way through to blah blah blah. But it did. Let's keep it on screen for a bit longer so we can actually admire our work here. All right, I'll just recycle this. There it is, okay, 0 all the way through to 4, 4, which would be the very bottom right corner. Okay, so there's all of our components, or pardon me, our coordinates that were made by their component, and that was the purpose of this video. So the brain of our inventory is officially online. We have a working coordinate system and a way to track every single item in the project. Next week in episode 3, we take this logic and start building the visual grid UI so we can actually see our items in the world. It's going to be a big one, so make sure that you're subscribed and hit the bell. If you want to learn more, you can watch these videos up here until the next Tarkov video comes out, and don't forget to subscribe. Special thanks to my Royal and Sovereign members. If you want to join the realm and get access to the rest of the course right away, visit my website, takinggrace.com. Thanks for watching, and if you have questions, I'll see you in the Discord. If you're a noble member or higher, I'll see you on the next video. Otherwise, keep learning till you game over. Peace.